Hey guys, here is Unit 2's notes on proving lines parallel and perpendicular. Here's some facts that we already know about parallel lines. These are those special angles that I was talking about last week, and even today in class we were talking about corresponding angles are congruent. So basically, if two lines are parallel, then the corresponding angles are congruent. And corresponding angles, if you remember correctly, are angles that look like this. You would have angle 1 here, and then this would be corresponding angle 2. So those would be corresponding angles, angles that are in the same spot. So if I took these four angles, cut it right here, put these four on top of these four, 1 and 2 would land on top of each other, and they're congruent. We also have alternate interior angles are congruent. If I have angle 2 right here, and I put angle 3 right here, those are alternate interior angles. And you can kind of tell, look at how big these three angles are. Angle 1, 3, and 2 are all obtuse angles. They're all congruent here. Because these two lines are parallel to each other, it's making the same angles. We also know that alternate exterior angles are congruent. So if I was to put an angle 4 down here, you'd have 4 and 1 are congruent. So let's recap. Our corresponding angles were 1 and 2. Let's put this in red so you can see the difference. Corresponding angles are 1 and 2. Alternate interior angles were 2 and 3. And alternate exterior angles were 1 and 4. And you will notice that all of those angles, all four of them, are obtuse angles. They're all congruent. Because corresponding angles are congruent, alternate interior angles are going to be congruent, alternate exterior angles are congruent. And we could have done the same angles with the acute ones too. We could have done this one here in the top left with this one right here for corresponding, this one with this one for alternate exterior. We could have done this inside acute angle and this inside acute angle for alternate interior. So it's either they're both obtuse, they're going to be congruent. They're both acute, they're going to be congruent. The last set we talked about was consecutive interior angles. And I made a mistake there. They're not congruent. Consecutive interior angles are supplementary. I think I caught that. Okay, so they're supplementary. That means that they're going to add up to 180. I'm going to put another angle right in here. Oops. Let's put this as angle 5. And 5 is acute. But if I look at angle 5, and I put it together with angle 3, these two angles, those two angles together are going to add up to 180. They're going to be supplementary. So that is the meaning of supplementary angles. When they add up to 180, these are called consecutive because they're right next to each other and they're both interior. So consecutive interior angles. That's just a review of what we did before. So there's a quick review. Now we want to talk about how do we actually prove that the lines are parallel. And in this top situation, we were given that the lines were parallel. Now we want to say, well, what if we wanted to prove that these lines are parallel? So we're going to use what we call the converse of these statements. You will hopefully remember converse when you flip a statement around or when you switch it. So let's pick one of the above and write it as a conditional statement. So let's pick alternate interior. Let's do that one. So here is the statement. Let's go ahead and do it red. We'll make it a little bigger. Okay, let's make a conditional statement, so it's got to have if then. If alternate interior angles are congruent, then the lines are parallel. Okay, so that is Wait, we wanted it. That's what we want to put down here. So hold on a second. Redo. Sorry, that's not the conditional I want. Hold on, hopefully use pencil. If two lines are parallel, then alternate interior angles are congruent. That's the conditional I wanted to start with. Okay, so we said that alternate interior angles are congruent when these two lines are parallel. And I could actually even put an arrow on those two lines. Now that's what we use for parallel, is when we make an arrow. I need to make it a little bit bigger so you can actually see it. So if I was to put an arrow here, that's the symbol for parallel. And then you copy that and you put another one down here and you've got parallel lines. That's what that means, parallel. Now we want to write the converse of this statement. Alright, now we want to write the converse of the statement that we chose. So the converse would be what I wrote initially. It's if alternate interior angles are congruent, then the lines are parallel. So if we can prove that alternate interior angles are congruent, so if I could prove that angle 2 is congruent to angle 3 here, if I can prove that those two are congruent, then the lines have been proven to be parallel, because that's the only way they could be parallel, is to have the same angles, which would make the same slope. So if I can prove alternate interior angles are congruent, then the lines are parallel. And this statement we call the alternate interior angle converse. And that is one way that we can prove that lines are parallel. We could have used the corresponding angle converse, the alternate exterior angle converse, the consecutive interior angle converse. Any converse of these four statements would prove to us that the lines had to have been parallel. Let's go to the next one. Okay, here's an example one. Brittany knows that if mirrors are parallel in a laser, which is where M is parallel to N, here's yellow is the mirror. So the laser is coming up to this first mirror, and it's banking off the mirror going to the second mirror. It's banking off that mirror, and it's coming up, and they're going to make parallel lines. So in this case, the mirrors were on parallel planes, and angle 1 is congruent to angle 3. Then the paths of the laser beams along A and B will be parallel. See if Brittany is correct. So we've got, given is that M is parallel to N. So M is parallel to N. That's given to us. So this time we're not proving that the lines are parallel. M and N are parallel. We're trying to prove that lines A and B are actually parallel to each other. That's what we're trying to prove, is that these laser beam lines are parallel to each other. They come off the mirrors at the same angles. So this first one for A is given. That's our A. Now angle 1 is congruent to angle 2 is because they are alternate interior angles. Now the only reason I can say they're alternate interior angles is because they already proved to us that these two lines are parallel. I couldn't use that if the lines weren't parallel, but they already told me that M and N were parallel to each other. That means that alternate interior angles have to be congruent between these two lines, not between A and B. I don't know if A and B are parallel yet, but I do know that M and N are parallel. So that means 1 and 2 have to be congruent because M and N are already parallel. That means they're already making the same angles. So 1 and 2 are alternate interior angles. 1 is congruent to 3 is going to be, let's see. Oh, that's given to us, sorry. Spacing out there for a second. So that's another given statement. They gave us the fact that 1 and 3 are congruent. And I missed an angle symbol up here, so let's fill that in really quick. So 1 and 3 are congruent. It's a given statement. Now, 2 and 3 are congruent. 2 and 3 are congruent. we have to see why 2 and 3 are proven to be congruent, and that would be because, if I can get this to work, okay, that would be because the congruent supplements theorem, if you remember in class today, we talked about that. We talked about the fact that we were talking in class today that angle 1 makes angle 2 add up to 180. Angle 1 also makes angle 3 add up to 180. So 2 and 3 are both making angle 1 add up to 180. That means 2 and 3 have to be equal to each other because they both made angle 1. Whatever angle 1 was, they both of them made it add up to 180. So they're congruent to each other. We call that the congruent supplements theorem. And then because of that, those angles 2 and 3, you can tell they're in the same position. If I was to pull these 4 angles and bring them over here, 2 would land on top of 3, so they have to be corresponding angles. So we can prove that these A and B are parallel to each other. These two are parallel because of the corresponding angles converse. The converse is what we're allowed to use to prove that they're parallel to each other. Alright, moving on. One more way to prove that lines are parallel. So we learned that there are 4 ways so far. We could use the converse of the corresponding angles. We could use the converse of the alternate interior, the converse of the alternate exterior, the converse of the consecutive interior. We can also use the perpendicular parallel theorem, which basically says if 2 coplanar lines are perpendicular to the same line, then the 2 lines are parallel. If they're both perpendicular to line C, then A and B have to be parallel. So basically what this is saying is that if angle 1 is a 90-degree angle to A, if line C is a 90-degree angle to line A, and line C is also a 90-degree angle to line B, then line A and B had to be the same because they had to both be 90 degrees. So they had to be parallel to each other. So we could call it the perpendicular parallel. You could have also said corresponding angle converse, because 1 and 2 are the same angle. They are in the same position. So corresponding angle converse would also prove that A and B are parallel. Okay, proving lines are perpendicular. Last slide here, and then we got a little challenge on the next one. Example 2: the side view of a gable end of a house shows beam DB, which is this beam right here, is perpendicular to cross beam AC, this one right here. If a carpenter knows that the measure of angle 1 is 40 degrees, so immediately I would write the number 40 degrees on my picture if I was doing a test or something. I would just want to visualize it where everything is, so I'd put 40 degrees right there. I know that angle 1 is 40, and that the measure of angle 1 equals the measure of angle 2, so immediately I would put arcs in there. So I know angle 1 is congruent to 2. That's not a great arc, so let me do a different one. Let's try this one. Okay, so I know 1 and 2 are congruent. How can the carpenter find the measure of angle 3? This one down here. So if the 2 lines are perpendicular, then they form a right angle. So we already know that these are perpendicular right here, because it says DB is perpendicular to AC. So we know that there is a 90-degree angle right here. That is a 90-degree angle. That's given to us kind of in this scenario right here. The fact that they're perpendicular gives us that. So we know 2 and 3 then are going to be complementary angles. They're going to add up to 90, 2 and 3 together. So given to us is that DB is perpendicular to AC, and that ACB is a right angle. So we know that ACB is a right angle. So for us to find angle 3, we know that angle 1 plus angle 2 is going to equal 40. Or no, angle 1 equals angle 2, which equals 40. So that means this one's got to also be 40. If I know 1 and 2 are equal and I already have 40 degrees on 1, that means I can put a 40 degrees right here as well. Okay, now I already said I know 2 and 3 add up to 90. So if 2 is already 40 degrees, that means, well, we can say that 1 and 3 add up to 90. And that angle 1 is 40 degrees. This should actually have been angle 2 right here. 2 and 3 add up to 90 would be better. We know 1 and 3 does also, but this would probably have been better if we would have put a 2 right here. So 2 and 3 add up to 90. We know angle 2 is 40 degrees because 1 and 2 are equal to each other. I think they put 1 before because 1 was up there, but I think 2 would be better there. And then if you subtract 40 on both sides, the measure of angle 3 has to be 50 degrees. So this one right over here, we could easily write down has 50 degrees. So 40 and 50 add up to 90. We knew these two together made a 90-degree angle because it said perpendicular. When you see perpendicular, you know you're going to have 90-degree angles. So two lines that intersect to form a right angle would be perpendicular. All right, the last challenge. First person that can tell me tomorrow how many triangles are in this picture. Pause it, draw it, whatever you need to do, write it down, figure out how many triangles are in that picture. And good luck, and we'll see you guys tomorrow.